Okay, we still got 6, so I'm gonna get started. If people join in, I'll start with some admin work. So again, thanks guys for joining. Thanks guys and gals. First, the cool announcement, which is I'm gonna start recording these like I should have been doing for the past 2 years. Turns out I did record 2 in the past. So those 2, along with eventually this one, as soon as we're done, I'll push stop, it'll generate the movie, I'll put it somewhere. But to find them whenever you want them, it's on my website. So https://armion.com/meetup. I'll put a link here. I'll do my best to put it on the meetup. So armion.com/meetup. And it just takes you to this page, which right now you can download the one about APIs, and then one about references and values and mutability. So click on the link, and it will first take you to a page that asks you to pay $1.99. So they're not free. It helps me continue this meetup. So it's the least that I could ask from you guys. It's not too much. I prefer you to be here live, but anybody who can't make it, you know, I want to start making money from these things so that I can start paying meetup back. So support me, support the meetup. If you're enjoying it, click download, and I promise it will take you straight to a secure Stripe page. You'll see all the typical stuff in my name, pay $1, and it'll give you the link to download it, I promise. And if you have any problems, let me know. I want it to be as painless as possible. But this one will be up very soon. So armion.com/meetup. Okay, tonight is an interesting one. So we're gonna use a thing called promises as a way of introducing you all to this notion of asynchronous programming. So asynchronous as opposed to synchronous. And the best way that I can differentiate the two, I'm going to use one of the most popular books on JavaScript and programming. So mini plagiarism, but also I encourage you to try to read the book. I still struggle with it, but it's a great book. It's called Eloquent JavaScript. It's free online, eloquentjavascript.net. And I have highlighted a section from the 11th chapter on asynchronous programming. So let me close this up. And these 2 paragraphs, let's just kind of read them and try to understand. So synchronous, things happen one at a time. One. When you call a function and it takes a while to run, that function only returns when all of what it's doing, it has a result and it can come back. So this stops your program for the time that it takes that function to run. Enters the function, does all the stuff, returns you back a value. The beauty of asynchronous is that it allows multiple things to happen at the same time. And that can seem weird. You might wonder, how the heck is it doing that? Well, when you start an action, your program continues to run. So there might be a function that's being called. Well, the result of that is going to go off and do something so that the rest of your program can keep running. But that means that if you're trying to get a value out of that thing that went off and kept running, you don't have that value yet. So when the action finishes, the program is informed and get access to the result. So the next question is, wait a second, how is it being informed? When is it being informed? Do I have control of these things? Do I not have control of these things? What is all this getting at? But ultimately, synchronous means from line 1 to line 100,000, it reads line 1 and does it and then returns something. Line 2, it now has what happened on line 1 and keeps going all the way down. Asynchronous, you may not necessarily have the result of what happened on line 3 by the time you get to line 4. And that can be confusing when our brains look from top to bottom and want to think, ooh, this happened first, second, third, fourth, fifth. We will see very shortly that in an asynchronous model, that may not be the case, which again blows the brain up. But hopefully by the end of this, I'll help you see some warning signs and we'll wrap our heads around it. So asynchronicity, it's a long word, it's jargony, but that's it in a nutshell. So more articles and places to find helpful little tidbits about asynchronous programming. This is Mozilla's Developer Network, or MDN for short, which whenever you Google something web-related, you're likely to come here. And I'm on the asynchronous JavaScript page. They have a specific section dedicated to it. You'll notice they say it's a fairly advanced topic. I agree, but I don't think that prevents us from learning it as beginners. So there's plenty of guides on all things asynchronous JavaScript. I encourage you to check some of it out. We're going to touch on a bit of it tonight, which is timeouts, promises, and then at the very end, I will touch on these really two keywords that are new, maybe in the past 2 years, that you're likely to hear a lot if you're anywhere around senior JavaScript developers. Async Await is a very, very new, modern, catchy, and rightfully so, handy way of working with asynchronous programming. But again, it stinks if you don't quite know what it's doing or what it means, because as I'll show you, these two words do a lot in JavaScript that are under the hood and you may not be aware of. So let's turn to promises. Before I go way into it, just real world. What is a promise? If someone makes you a promise, that means one of two things: that they made you a promise and therefore nothing tangible has been acquired yet. A promise by its very definition means something soon in the future is either going to happen to my advantage, meaning they come through on their promise, or something happens where they don't follow through on their promise, and it's as if they had betrayed me somehow. So a promise it's very similar in JavaScript. It's an object, and it represents the eventual completion or failure of an asynchronous operation and its resulting value. So when you have in your hands a promise, then that means you don't yet have the value that you want. You're going to get it soon when the promise resolves. And that's the whole nature of asynchronous programming, is this notion of thinking you might have what you want, but really something's going to happen, something's going to go off and do a bunch of work, and then your program will eventually be informed of when the promise has resolved, and you can queue up a bunch of work to happen when the promise resolves, hopefully with all the data that you get back. But you can also queue up something to log out the error if the promise didn't resolve the way you expected, so that you can handle those errors. So this shows a little bit of code. I'm probably going to jump into my own code in a moment that doesn't quite use promise. But the way that we're going to explore promise is through a very, very handy API that's in the browser, and it's called the Fetch API. And odds are, when you're working with asynchronous programs or code, you are likely sending a request to an API. You want a list of tweets. You want to get all the recent blog posts. You want to get the weather. You want to have a to-do list. And you either want to create a to-do list and store it to a database and then get a response from the database to say, hey, we successfully stored it. You want to send something to Twitter that gets you back that list of the latest tweets. And that's great, but again, you need to send a request and you need to go to their servers, get it all. That takes more than 0 seconds. So you're sending a promise to say, hey, Twitter, do you promise me you'll give me back data? So most of this stuff, all things promise and asynchronous, coincides very nicely with pinging other servers for data. And that's, generally speaking, using web APIs. So this Fetch API lets us do that fairly easily. And under the hood, Fetch creates and returns a promise. So that's why we're talking promises. As it says here, provides an interface for fetching resources across the network. And if you've ever heard of this wacky thing called the XML HTTP request object, or XHR, that is hell to deal with, and Fetch makes it a lot easier. But let's scroll down here to kind of the good stuff here. The fetch method, and that means fetch is a function that you can call, hence the parentheses. So fetch is just a function, but what it does in the running of that function is eventually, at the end of it, it returns a promise. So you'll call fetch, and what you get back from fetch, what you get returned from fetch, is this thing called a promise. And the promise will then eventually resolve to have a response. So it is twofold. There is kind of a linearity here, but it can be really confusing to be like, okay, wait, I'm calling a function. What I get back from that function is this thing called a promise. That's not what I want. I want the thing that the promise eventually resolves to. So it can be very confusing, but again, I promise to show you what this all means. was really hoping not to use puns tonight, but I couldn't avoid it, apparently. Okay, so in a little bit, I'll show you an actual fetch call of using the function and getting stuff back from it. But again, all we're going down here is in your JavaScript, how do you write code in an asynchronous way, and what happens when you write it that way inside of your code. So let's do a little kind of example here. So hopefully this is big enough for you guys to see it. It's huge on my screen. I've more or less got 3 lines of code here. So the first line, I'm going to log just a string. This is the first log. The next bit of code, I am using this thing that I get from the browser. It's called set timeout. It is a function that it will run, and then it will literally wait this many milliseconds. So oddly enough, I am telling it to wait 0 milliseconds. So you would think it would run immediately. I am passing it a function. If you are unfamiliar with the syntax, it is this new ES6 arrow function syntax, but this is just a function. And inside of this function, I'm going to log another string of text. So if we think linearly, synchronously, we would think, well, this is going to log first, and then I'm going to see this message, and then I'm going to see this message. That would be the smart, well, not smart, but just that's how I would generally think. This runs, and then I get to this line, and this whole thing runs, and then I get to this line, and this whole thing runs. But turns out that may not be the case. So let's go ahead and run this. I'm just going to run it on my machine using Node. So I'm going to type in, and hopefully you can see this. I made it as big as I can. So I'm going to run this program, and 5-second break for what order do you think these will appear in? First, second, third, first, third, second, second, third. I mean, what will it be? Let's find out. We see first log, third log, second log. So that might be odd to some of you. We log this first, and then somehow this was logged before this. So again, why is that? And that is because set timeout is a sort of asynchronous function in that the browser will read and execute this line. And when it reads and executes this line, set timeout actually does a bunch of stuff under the hood in the browser, and it kind of goes off into its own little space. And this function will get run. The problem is when it's done running, the browser puts it into a completely separate queue, and the browser at all times has this thing called an event loop, and it's checking it, but it only checks it after the entire rest of the program has been completed. So it runs this line, it runs this function, which merely sends a task off in the browser somewhere and says, hey, go do something, and then when you're done doing something and I check for you again, then run this code. So again, this code is not getting run right here on line 5 before this code. It is happening possibly way later. So set timeout goes and does something in the browser, queues something up. Then this line runs, and finally our program says, okay, the main program is done running. I should probably check my queues, do another loop through the event loop, and see if anything has been queued up. And when it does that, it sees, hey, set timeout has finished. It's also got a function attached to it. I better run that function. The whole program's done, check the event loop, this thing's here waiting for me. Cool, I'm gonna go do you now. And then it finally logs the log. So while this code looks synchronous, while you think it would run this, and then this, and then this, and then this, and then this, this whole, like, you just have to kind of know, sadly, that this function is really queuing up work to be done later, assuming that it's happened. Even though this 0 right here makes me think it's going to run right away. So let's do, like, that was logging stuff, but let's go a little bit further here. So I'm going to delete this, and our next little example will actually use kind of a value, and we're going to change it. So first line, I assign the number 2 to this value. Second line, I'm going to log the value to the console. Here we again see set timeout. And the only thing I'm doing different here is not just logging something, but I am changing value to 3. So in this function that I passed the set timeout, I'm changing value to 3, and then I'm logging it. And then the last line is the end of my program, and I'm going to log the value again. So now we're actually changing things. We're not just logging things. The question is, when I come to this log, what do we expect value to be? What do we think value will be? And I'll let you kind of guess on that. I'm going to do it in a moment. But will it be 2 or will it be 3 is kind of the big question. So let's go ahead and run this again. And we not only see that first log printed first, but then end of program printed before after time, which hopefully for the last example makes sense. But also with end of program, at this point right here, value is still 2, it's not 3 yet. And then after the timeout, it is 3. And hopefully after seeing the last example, you know why, because this function didn't run until we got to the end of our program. The browser or node checked that our program was done, everything was out of the sort of call stack, and then it said, oh, let me go check my event loop. Oh, it looks like set timeout finished, and I can run this function now. And then it runs the function, changes value to 3, and does this. So the purpose of this example, yet again, is to show you novice developers will read this top to bottom and think, oh, value is 2, this function runs and changes it to 3, and then it gets here, and by the time I console.log this, value will be 3. And the unfortunate truth, if you don't understand asynchronous programming, is no, value is still 2 here because this function has not yet run. So there's one of the big kind of aha moments here is just because you're reading it top to bottom doesn't necessarily mean it's going to be executed in that order. Set timeout certainly was run. This function, this outer function was called. Unfortunately, if you're unaware, this inner function has not run yet because, again, the whole program has to run first, and then the calling space, whether it's the browser or the server, then goes and checks the event loop, sees that there's a function ready to be run because set timeout finished, and then ran it. So again, it can all be confusing. It gets even scarier with things like callbacks, and luckily now we have promises. But kind of the last thing to show, or I guess, well, here's the last thing to show, is I'll show you fetch. So we saw one example. We now know, hey, things don't quite go in the order we might expect them to at first. So cool, at least we kind of know that now. But let's look at this. So if we uncomment this out, I am initializing a variable called promise to just be null, nothing's in it. Here is what may look very scary, but I'm calling fetch. So let's go ahead and just kind of break this down a bit in the browser. This happens to be a URL endpoint that is free. It's a really cool kind of thing. If we go here, there's this website, jsonplaceholder.typeitcode.com. If you ever just want to mess with like fetch APIs, you can use this one for free. Most APIs require you to create an account, add billing, create a key, do all that stuff. And I didn't want to have to do that for tonight. So I luckily can just use this, and calling it with this string won't return an error. So first, let's just see what calling fetch does for us. So I'm going to go back to the browser. Let's open my console here. And luckily, I can just literally type, I can just call fetch. Fetch is available to me in the browser for free with this string. And when I call it, you'll see, and if I make this a little bigger, that what fetch returned to me, as expected here, fetch method takes one mandatory argument, the path to a resource. It returns a promise that will eventually resolve. So if I come back here, it returned a promise that is technically pending. So here we have some gobbledygook, but its status is apparently resolved, and the value is the response. And if we open this up, all of this stuff is the response. We've got a body, it's this readable stream, a whole bunch of things. So cool, that's what fetch returns to us. But the whole point of using fetch and promises is once it returns, we kind of want to queue up a bunch of things to happen so that when it has returned, we eventually get the data that we want. So we don't want a promise, we want the response's data that comes from the promise. And that's what all of these little .then things are. These .thens, I am calling a function called then that is actually on the promise object that is returned from fetch. So while it may look here like I'm calling .then on fetch, I'm calling then with the little dot here on the result of calling fetch, which will be a promise. So and it's a really kind of terrible term because you might think, okay, fetch runs and then this runs and then this runs and then I'm now on to line 13. But what then is really doing is queuing up a function to run, and each time then runs, the function's going to get something passed to it as an argument. So the first time that we call then, this function is expecting some sort of object called response. Like it knows it's going to get that, so I can write that here. And it's going to return the JSON parsed little bits of that response. So that's nice. I can queue this function up to run once the promise return from fetch eventually resolves. And it's confusing, it's a little interconnected, and I apologize if I'm going maybe a bit fast here. So we call then, we get this response, and the nice thing is calling .then, like after this line is run, this now all is linear. So after I've called this, I can then call then again because this line returns yet another kind of, well, it actually just returns the value that I'm getting from this, but it is another object that has a .then method on it. So it is another promise that's kind of already resolved. So I can kind of go and chain these things and just keep saying .then, .then, .then. And I know that at least within the confines of this code, I am working with the same data. I'm just kind of passing it through a bunch of pipes. So this function does something to the response. And then this function, I'm calling this JSON because I'm now working with whatever has been returned from this expression. So now I'm working with JSON, and good news is I'm going to finally set this JSON. I'm going to update my little variable up here with finally this JSON data. And then I'm going to log it to the console. So all of this will happen after this line runs. That's the most important part from all of what I've been teaching you tonight. This line runs, this line will run, but all of this won't run yet because this has to resolve to a promise. And then by that time, this line will have run, the program will kind of have finished, and the browser or wherever will have checked, hey, anything in the queue for me to respond to? Oh, hey, look, I got a promise that was returned from this thing. Looks like it's resolved. Let me go and run each of these little functions. So let's kind of see how this works. I have to do it in pieces. In fact, if I just do all of this, and we come over here to the console, I clear it out, let's see what happens. So we paste it all, push enter. I got promise equals null, and then this runs last, happened first. That's what this line is right here. And promise is null at this point. So again, the whole point of all this is promise is not JSON yet. All of this has not run. And then we get undefined because something's returning something and it just has undefined. But then finally, when I do console.log after fetch, all of this code has finally run, and I indeed have the data, the JSONified data that I was expecting. So yet again, this runs, and then this line runs because it's a function that's going to trigger a bunch of code to happen in the background asynchronously. So that's going to happen, and I can now proceed to the next line of my code. So this is running at the same time whatever is happening here in the background is running. That is the asynchronous part of this. When I first thought of it, I was like, wait, I can't run this line and this line at the same time. Well, no, it's actually something is happening in the background or on a server somewhere. Work is being done outside of your program. That's the whole asynchronous part. So this runs, and then finally, when this returns, I can run all of this code. So this is all asynchronous. Promises are a much better way of doing it than callbacks. Callbacks are this nested gross function thing that hopefully we're done with these days. But there's a level up from promises. and it is this notion of async await. So, the beauty of async await is that it kind of lets you think more in a synchronous manner. So you can say var promise, and all this stuff has to happen in a function. So if I have a function who blah, blah, blah in here, I can say var promise equals, and instead of null, I might say I want you to await calling fetch. So I would put it here, and this handy keyword await, in conjunction with making this a very special type of function. So an async function plus the word await will basically, it will get to this line of code, it will run fetch, and then it will more or less stall this function. It will stall it right here. Nothing has been returned to promise yet. It will then exit out of that function and run the rest of your code. And as soon as this has resolved, it will store it in promise, and we can then do things like promise dot then blah, 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 blah. So it makes it feel more like we're writing synchronously when really there's a bunch of asynchronous stuff happening in the background. And what I just want you to know is that this is really shorthand. Like async and await are two 5-letter words that make it really easy to write asynchronous code. But the crazy stuff happening in the background, if we come over here, and so here I'm in a tool called Babel. It's online. It's what all of the crazy React, Vue, they all use it because it lets you write new JavaScript today that things may not understand. So I'm in a tool. The left-hand side is the code that I want to write, and the right-hand side is the code that Babel generates for really old browsers. So what you're seeing is I wrote this function sync foo, and it returns 2. And here is indeed the function as it would be written by Babel. But let's see, if I zoom out a bit here, let's see if I just use the word async and I use the word await, and all I'm doing is assigning it to a value. I want you to have shock and awe as to all of the crap that Babel has to write to make this function work as expected. So remember, all you're writing is 3 lines of code, but what really gets run, and I really hope this is eye-opening for you guys, is all of this crap. All of this is what it takes to let you use the word async and the word await. There are things called generators in here, iterators, these crazy complex objects that no one wants to have to waste their time learning. But all of that is happening behind the scenes just to let us create an async type function and use this handy keyword await to write asynchronous code in a manner that feels more like our brains want to compute it in a synchronous way. So man, I've been talking for half an hour. I hope you guys have learned at least a little bit to feel more confident reading and maybe writing asynchronous code, remembering that the function finishes, but some work goes off and does things, and your code keeps running, your program keeps running until the end, when the browser then finally goes, looks up those old things to work on, picks them back up, and does what it needs to. But just remember that reading top to bottom, you may not have the value you think you do on the next line because it may be asynchronous and not available to you yet. And promises are a great way of learning that. So we got almost 4 minutes left. It's probably going to cut me off, but I'm done. Feel free to unmute yourself, ask questions, let me know. But hopefully we covered a lot today and you have more ammunition to go and learn it yourself. But yeah, I'll hang out for questions or just to chat. We got about 3 minutes before this will end. Oh, Mike, you're, were you saying something? Here, I unmuted you, Mike. Were you saying something?
Robert?
Yeah.
You're muted.
I'm muted? No. I'm not muted.
So if you didn't have the word await there, what would happen?
If I did not have the word await here, a lot less code, but it is the word async.
You're still muted. Did I do something?
No, I think you're.
I did. Sorry, I did it. My bad.
Okay. Yeah. So the word await, the word async is what does it.
Can you put the word async there, but then take the word await out, or did
await does not work without the word async.
But does async work without the word await?
Yes, as we can see here. So await, bad. You can do an async function with nothing else. Async is what does all this code. So you can create an async function without using await, but that would kind of be pointless.
Yeah, because it looked like it did it. It does it naturally.
Yeah, well, so the whole point of async is to be able to use this keyword await, which is really the bread and butter.
Okay. All right.
Await is what I would love to use await without async, but async's required to set up all these stupid generators to do what they need to.
Okay. All right.
Good question. Yeah, it looks like I got less than a minute. So out of fear of this thing disconnecting us, looks like you're all very quiet. Mike.
So the return does the same thing? If the return, it'll return a value and it still have ran code afterwards in a function? Let's say you got to return something.
Yeah, no, yeah, so you should still return stuff from here.
But it can happen after the next line in code, though. The return can happen after. Okay.
Yeah.
That's not good.
No, it is. Just I need to understand it a bit more. I only had so much time tonight.
Oh, okay.
Yeah, and we're going to end in a bit. So without it cutting us off, thank you guys so much. Appreciate it. Thanks for joining, and hopefully the next one very soon. But cheers,
See you next time.
Cheers, guys.
Bye.